So today what we'll do is we're going to work with fractional exponents. First of all, we're going to use a calculator to develop a pattern, but you're going to be expected to be able to attempt these without a calculator. So, for example, the first problem that we have here, 36 to the 1/2, we're going to evaluate that. On your calculator, you would actually write something that looks like this: 36 to the exponent of 1 divided by 2. Once you calculate that, you'll realize that's 6. We'll do the same thing for this next one. You find out we have 49 to the exponent 1 divided by 2, which ends up being just 7. The same happens for this. Answer is 10. For this one here, we're going to end up with 1/3. We're going to end up with 1/3 for our exponent. Exponent 1 divided by 3. And we get 2. And the next one we have here is 81 to the 1/4. One divided by 4, and your calculator gives you 3. For the first one, we call this the square root of 6. The next one is the square root of 7. So if you looked at this, you could have done this. The square root of 36 is equal to 6. We could have done this one. The square root of 49 equals 7. Now, when we say something is a square root, we're really saying that there is a 2 on the root sign. So it's saying, find me two numbers that multiply together to give me, say, 36. And that answer is 6 here. And this one says, give me two numbers that are the same, multiplied together gives 49, and that answer is 7. The same can be said about 100. So I could have written that as the square root of 100, which equals 10. This one here, we would actually write, notice we had 8 to the 1/3. So we could use this. We could go the third root of 8. Well, that's just 2. The same could be said with this. Instead of having a square root, now we're going to have a fourth root. So we'd say the fourth root of 81 is equal to 3. So here's the rule that we're picking out today. In general, if I have anything that's raised to the 1/n, my answer is the nth root of x. For this first problem here, we'll change 8 to a 9. Now, that really means that this is the square root of 9. Now, in order to compute this on your calculator, what you have to do is the following. You literally have to hit 2, shift, y to the x, and then hit the number 9 on your calculator, and you end up with 3. So 27 to the 1/3 is just, well, the third root of 27. So on your calculator, you would have hit 3, shift, y to the x, and then hit 27, and your answer is going to be 3. And we'll do the same for each of these. Now, this next problem here, -64 to the 1/3, in order to punch that in your calculator, you actually have to put the bracket. So for you, you're going to put 3 root -64. On your calculator, you would write 3 shift y to the x times, in brackets, negative 64. And you would end up with negative 4. Do the same for the next one here, negative 81 to the 1/4. So we're going to have the 4th root of negative 81. Punch that in your calculator and you're going to get negative 3. Now for this next one, we really want to say that the exponent is only applied to the number that's directly beside it. In this case, it's 64, or the bracket that would be directly beside it. So in this case, we want to say that this really means negative 1 times 64 to the 1/6, which really means negative 1 times the 6th root of 64, which ends up being negative 1 times 2 when you punch that in your calculator, which ends up being negative 2 as our final answer. For our next set of problems, we're going to work with what I call crazy exponents. They're not as bad as you think, they're just ridiculously annoying. So if we talk about these crazy exponents, suppose we have something that is not 1 over n. So if we calculated this on our calculator, we would end up doing something like this. For 16 to the 3/2, you'd write 16 on your calculator raised to the 3 divided by 2. Now, and the same would be said for 27. So you'd write 27 to the exponent 2 divided by 3. And the same could be said for 100 to the 5 over 2. So you end up with 100 to the exponent 5 divided by 2. When you punch this into your calculator, you end up, when you punch the 16 to the 3 over 2, you end up with 64. But you recall that if you think about this, remember the 2, the denominator on our fraction, basically made this be square rooted. So that means our original answer was the square root is 16. And you know that the square root of 16 is equal to 4. But then, in order to get 64, that means we would have had to cube this. Cube the 4. Cubing 4 gives us 64. Oh. So basically, what it says is, because we have the denominator being 2 in our exponent, and our numerator is a 3, it says, first take the square root of our 16. That's what the 2 means. And then the cube tells us once you've taken the square root, you're going to cube it. The same could be said for each of these other equations here. Now this one here is equal to 3. But when you go back and do the problem like we just did, you have the 3rd root of 27, which is equal to 3. And then we go back and we square the whole thing. And we end up with, and so that means that this answer here is incorrect. So I'm going to scratch that out, and our final answer is 9. For this one here, we end up with 1 with 1, 2, 3, 4, 5. All right. Now let's not bother with this. I don't have time for this. Let's take a look at the general rule. The general rule says if I have an exponent of m over n, we're basically taking the nth root of x. So the denominator goes inside on the root sign, and then our exponent goes on the outside as a raised power. So it's literally a power of a... Now, let's do each of these problems here. Using the rules, we're going to get this. Well, for 25 to the 3 halves. So remember, our half goes inside. And then on the outside, we put our 3. So we take the square root of 25, we end up with 5 raised to the power of 3. Our final answer is 125. Because we write 5 to the exponent 3 and we're done. You'll notice how every time I do these calculations, I ensure that I make sure that my root sign is in a bracket. You're going to do the same for everything that's on this set here. So now for the next one, we have the 4th root of 16 all raised to the 7. The 4th root of 16, well, that's just 2 raised to the 7. So notice the 2, the result, is always put in a bracket. So we have 2 to the 7, which equals 128. Now let's do the next one here. So we're going to go equals the 4th root, oh, not the 4th root, it's the 3rd root. The 3rd root of negative 27. So remember that the denominator of the fractional exponent goes on the inside on the root sign, raised to the 4. The 3rd root of 27 is equal to 3. And we're raising all of that, oh, negative 3 raised to the 4. So negative 3 raised to the 4 is 81. You'll notice that we have a negative sign here and we have a positive sign here. The reason why this is positive is because there's an even number on the exponent, and if it's an even number, that means that this final answer should be positive when we multiply it out. Let's go and take a look at the next one here. We have 64, negative 64 to the 5 halves. So we have equals the square root of negative 64 raised to the power of 5. Punching that in your calculator, you can't get anything. It's not a number. Now, it's very similar to what we had on our assignment. If we had an even number here and a negative number underneath the root sign, you can't possibly calculate that because there's no possibility of you finding two negative numbers that multiply together to give a negative number. This number 2 from the handout. For this next problem, we're going to write the fraction using the following example. If I have basically x to the negative m over n, basically what that means is it's 1 over the root of x to the m. Now, how does that come about? If you think about it, we can do this in one step, or this is actually showing how we do this in one step. But you can write this as x to the negative m over n, which is the same as, well, remember what happened when we had a negative exponent. We would write 1 over x to the m over n, and when we did that, we removed our negative sign when we flipped our base number. Now, upon flipping our base number, we use our old rule. X to the m over n is just, well, the nth root of x all raised to the m. Okay, so basically what we've just done is we've just been more efficient and gone from this step straight to this step rather than going to this intermediate step. If you're not comfortable with this equation or remembering it, just remember that you just need to flip your equation first and then change it into our radical form. Okay, so now let's do these all in exactly one step. So 144 to the 1/2 is just, to the negative 1/2 is just 1 over the square root of 144. Now calculate that to the 1. So now let's just calculate that. So that's 1 over 12 to the 1, which is just equal to 1 over 12. The same can be said for 8 to the negative 2/3. So you're going to write 1 over, well, you could write it as 8 to the 2 over 3, which is the same as 1 over the third root of 8 raised to the 2, which is just 1 over 2 squared, which gives us our final answer of 1 over 4. The next problem we have here is negative 64 to the 2/3. Now, I tend to do it the long way. You guys can do it the short way that I just gave you using this equation. So I'll do it the long way first, and then we'll do it the short way next. So we've got, well, this is equal to, well, negative 64, 1 over negative 64, all raised to the 2/3. Because of that minus sign, we've just basically flipped our equation. Now, next, we do this. There we go, 1 over negative 64, and we're doing the third root of negative 64 squared. By doing so, you get the following: 1 over negative 4 all squared, which is just 1 over 16. Now, if you use the rule that I showed you, you end up with the following. For this next side, you end up with, well, 1 over the third root of negative 64 squared, which is just going to be 1 over 4, negative 4 squared, which is just 1 over 16. And all you've just essentially done is just save this one step here. It's a little more efficient, but I tend to, this one's a little more efficient, but I tend to use this method here to find my final answer. Now, you're going to work on handout number 3 for these problems. Now, the next one is we're going to combine all our exponent rules. Now, for the final problem, what we're going to do is we're going to apply the same rules that we used for our regular exponents. Before, if we were multiplying two exponents, what we would do is we would add them, because we end up having 5 to the 3 over 5 plus 7 over 5. Now, because we're adding two exponents, we just add the numerators and keep the denominator being the same. So we get 5 to the 10 over 5. 10 divided by 5 is just 2. So we end up with 5 squared, which is really just 25. Now, let's take a look at this next problem. Let's say I have 2 to the 3 over 2, all raised to the, say, 4. Now, this is power of a power, which means that we're going to have to basically write our equation, our exponent like this: 2 to the 3 over 2 times 4. Now, as an aside, let's go through the math for the multiplication. 3 over 2 times 4 is the same as 3 over 2 times 4 over 1. because 4 over 1 is the same as 4. It's just changing 4 to a fractional form. Then when we multiply the tops together and we multiply the bottoms together. So 3 times 4 gives 12, and 2 times 1 gives 2. So our final answer is 6. So 12 divided by 2 is 6. So basically 3 over 2 times 4 is just, for our exponent, 6. And we know that 2 to the 6 is 64. So what I'd like you to do is I'd like you to continue with the rest of the note. Okay, so it's clear. You need more practice. So we're going to do another B value, C, and D problem. So let's apply the same rules again. This time, instead of having multiplication, we'll do division. So you remember that both of these terms have the same base, 8. But we notice that we're dividing, so we must subtract our exponents. So if I have 8 to the 3 over 4, and then this is division, so we minus negative 9 over 4. Computing that, you're going to get the following. Well, 8, the denominator of our exponent is still going to be 4. But now we have to take 3 and subtract negative 9. 3 subtract negative 9 gives 12. So 8 to the 12 over 4 is just 3. And 8 cubed is 512. Now let's do power of a power. Same rules still apply. So the base is still 8. And our exponent is going to be 1 over 4 times 8 over 3. Which ends up being, well, 8 to the 8 over 12. Now, let's see what that comes out to. This ends up being reduction of the fraction. We're going to get the following. 8 to the 2 over 3. So that ends up being, well, the third root of 8 all squared, which ends up being, well, 2 squared, which is just 4. The next problem is very similar again. So let's go and take our rules again. So we get 27 to the 4 over 3. Notice I've got a positive exponent. That's because I've just flipped my fraction. So now what I have to do is I have to apply the rules as we did before. So I've got the third root of 27 all raised to the 4. Third root of 27 is 1 over 3 to the 4, which is equal to 1 over 81, is handout number 4.